Welcome to the landing training mission. In this mission, we'll practice landing procedures in the A-10C using an instrument landing system ILS approach into Batumi Air Base. I've engaged the autopilot to keep us level and on course. Maintain airspeed around 200 knots as we prepare the aircraft for the approach. If you find it hard to hear my instructions over the background noise, exit the mission and turn down the world and in-cockpit sound sliders to about 50%. Landing is one of the more challenging aspects of any flight. A good landing will require careful control of the aircraft and use of various instruments in the cockpit for a precise approach under the direction of the Airbase Air Traffic Controller ATC. A landing consists of navigating to the destination airfield using TACAN or GPS navigation, configuring the radio to the airfield's ATC frequency, configuring the ILS receiver to the airfield's ILS frequency, navigating to the final approach fix as directed by ATC, and finally performing the final approach to fly the aircraft precisely down the glide path toward the touchdown point of the runway. Press the spacebar key when you are ready to begin. Because we covered TACAN navigation previously, we'll use the GPS component of the IGI to navigate to our destination in this lesson. The CDU divert page lists the 4 closest air bases programmed in the CDU as selectable waypoints. To access this page, let's first open the CDU page on the right MFCD with OSB 13. Now open the CDU nav page by pressing function followed by the 2 nav key on the UFC. Press OSB 10 to open the divert page. The divert page displays the closest 4 air bases with their corresponding bearing, range, and time to go numbers. Press OSB 16 to make Batumi Air Base your steer point. You can now use the navigation data block in the bottom right corner of the HUD to monitor the range and TTG to home plate. As indicated on the CDU FLD Info Field Info page, the ATC radio frequency for Batumi is 131.000 MHz. We now need to set our VHF AM radio to this frequency. Press the spacebar key to proceed when the VHF AM radio is tuned to 131.000. Good. We can now contact Batumi ATC for initial approach instructions. However, before we do this, let's also set up the ILS panel for the approach. ILS is a ground-based precision approach system that guides approaching aircraft to the runway using vertical glide slope and horizontal localizer radio signals. ILS beacons operate at specific frequencies that need to be tuned to by the approaching aircraft. Batumi ILS operates on 110.30 MHz. On the ILS panel, roll the mouse wheel over the left frequency wheel to first set the frequency to 110. Now roll the mouse wheel over the right frequency wheel to set the frequency decimal to 0.30. Power up the ILS receiver by right-clicking over the left frequency wheel. Let's now check in with Batumi approach and call our flight inbound. Press the HOTAS mic switch forward command or left alt and num plus keys on the keyboard to open the VHF AM radio menu. Now press F5 to select the ATC radio page. Then select Batumi approach, and finally F1 to call inbound. Take note of the inbound instructions you will receive. Press the spacebar key to proceed once you receive the vector to the final approach fix from Batumi ATC.
Batumi 1-1, fly heading 234, 435, QFE 29, runway 13, to pattern altitude.
Press the escape key on the keyboard to exit the radio menu. We'll return to it in a few minutes. We can now navigate to the final approach fix, which will be approximately 10 nautical miles off the runway. Pattern altitudes vary depending on the airbase and local conditions, but are generally between 2,000 and 3,000 feet AGL above ground level. Whenever you're ready, press the spacebar key and I will disengage the autopilot so you can make the turn to the heading provided by ATC. Autopilot is off. You have control. Turn to the heading provided by ATC. Maintain altitude. We also need to set the HSI course to the runway heading of 130 degrees in order to get correct CDI indication for final approach. To do this, roll the mouse wheel over the HSI course set knob to set the HSI course needle to 130. Alternatively, you can press and hold the left mouse button while dragging the mouse left or right to turn the knob. Watch the HSI bearing window for the exact bearing. Let's also scale the TAD map out a bit so you can see the airbase steer point on the map as we approach. Make the TAD soy by pressing OSB 15 on the left MFCD, then press HOTAS DMIS down or the N key on the keyboard twice. Set the HUD as soy by pressing the HOTAS Coolie Hat up command or the U key on the keyboard. Because you'll want to concentrate on flying the aircraft once we turn on final, let's discuss now what will happen as we near the final approach fix. You want to hit the approach fix at approximately 2,500 feet and 230 knots indicated airspeed. As you approach the final approach fix, the CDI needle on the HSI will begin to move down toward the course needle. You will turn toward the runway to keep the two needles aligned to pick up the glide slope along the runway heading. As you turn, you will bleed off speed to below 200 knots and extend the landing gear and flaps for landing. Press the spacebar key to proceed when ready. Once the ILS signal is picked up by the ILS receiver, the glide slope deviation indicator will appear on the ADI. You will need to center this needle by gaining or losing altitude to see the pitch steering bar on the ADI for precise pitch control down the glide path. The bank steering bar will also appear on the ADI for precise directional control. Press the spacebar key to proceed when ready. Once established on the glide path, use the angle of attack indexer to maintain on-speed approach, around 120 knots or slightly less, because we are coming in light today. On the AOA indexer, the up arrow light indicates speed is too fast. The down arrow light indicates speed is too low. The O donut light indicates proper speed. If both the donut and an arrow light are on, the speed is only slightly off from on speed. Press the spacebar key to proceed when ready. In addition to ILS, Batumi Air Base is equipped with a Precision Approach Path Indicator PAPI light system. PAPI is designed to assist the pilot in maintaining the glide slope during final approach. It consists of 4 lights lined up horizontally near the runway threshold. The lights indicate either red or white. Your goal is to see 2 red and 2 white lights going from left to right. More red means you are below glide slope. More white means you are above glide slope. Press the spacebar key to proceed when ready. We'll keep the aircraft on autopilot until we get a little closer to the approach fix. If you wish, you can press left control and Z keys to accelerate time. Press left shift and Z to return to normal time. We are now approaching the final approach fix. Select ILS mode on the dim sill. The red glide slope warning on the ADI indicates that we are not currently receiving an ILS signal. The flag will be stowed and the glide slope deviation indicator needle will appear when we are closer to the runway. Whenever you're ready, press the spacebar key and I will disengage the autopilot so you can descend to pattern altitude. Autopilot is off. You should by now see the Batumi runway at about your 10 o'clock. When the runway is closer to your 9 o'clock, you will be nearing the approach fix. Check that the anti-skid switch is set to on. Descend to 2,500 feet. Maintain between 230 and 250 knots.